In this video, we are going to study about FET characteristics simulation. Our aim is implement and perform FET characteristics. What is FET characteristics? The FET is a unipolar transistor made up of semiconductor material which uses an electric field to control the current flow. The current always flows from the source towards the drain. A voltage is applied across the gate and source terminal, which creates a conductive channel between the source and gate. The electrons of holes flow from the source to drain in the form of a stream through the channel. There are several other things involved in the working and function of a FET according to their types. What we are going to discuss about characteristics of FET. The current voltage IV characteristics of the field transistor is plotted between the applied voltage VDS and drain current ID. The graph for studying the characteristic curve of a FET is plotted between the varying values of drain current represented by ID along the y-axis with varying values of VDS along the x-axis. The graph shows the following region. Ohmic region. This is the extreme left side of the graph, which represents the value of drain current ID when the applied voltage of the transistor between the source and gate is 0. That is, VGS is equal to 0. The conductive channel is small but narrow in this case. In cutoff region, our graph represented is by purple line. This cutoff region is also called as pinch-off region because the VGS voltage, the one which controls the current of the transistor, is terribly high enough to make the circuit work as an open switch. At the pinch-off region, the conductive channel for current is almost closed due to the increased thickness of depletion regions on both sides. Now, our next region is saturation region, or it is also known as active region. In this region, the field effect transistor acts as a good conductor. The value of applied voltage VGS, the voltage between gate and source, drives the transistor. The drain source voltage VDS has minimal effect on the current ID of the transistor at this very instant. And our last region is breakdown region. The voltage between the source and drain represented by VDS is very high at this point. The voltage is high enough that the conductive channel is broken and maximum current passes through the channel into drain. Now we are going to discuss about transfer characteristic. Transfer characteristic refers to the ID VGS plots of a field effect transistor that compare variations in drain current corresponding variations in gain voltage. It provides information on the transistor's control ability, with larger values indicating higher amplification capability. Now we are going to perform this experiment on LT Spice.
The FET characteristic stimulation. First, we require JFET. Keep it here. Then we require a voltage source. We'll keep one here and one here. Then we require a resistor. Rotate it. We'll connect the wires. We'll connect a ground here. This is the required circuit. Now we will name the components. Pick JFET. I will stimulate it. The TC sweep first source VGS. Type of sweep linear. Start value 0. Stop value -5. An increment of 1. Answer. Where add traces IDJ1. Okay. We'll see the graph. Now, if we in stimulation change the increment and run it, we'll see the graph become smooth. Now we'll see the output characteristics. Stimulation in the first source will be VDS, linear, start value be 0, each stop value greater is 30, an increment of 1. And in second source, give VGS, start value 0.5 -0.5 and stop value -3, the increment of zero point 0.5. Now we'll see the graph. Run it at tracer IDJ1. Okay. So we can see this graph. This is for 0.5, 1, 1.5. Like this, these are all the graphs. This is the output characteristics. We can take the readings of this